Okay, this is a short lesson on integration. Integration, you have the notation squiggly s f of x dx, okay? And that means I'm going to find the antiderivative of that function f of x, okay, which is the capital F of x is the antiderivative. So capital F of x is the antiderivative, that's what I need to do. The squiggly s dx is what's telling me to do that. This is also meaning to find the area under the curve. Now there's two types of integration. You have definite integrals or indefinite integrals. And the difference between them is that definite integrals has an interval to go from. So you're finding the area under the curve. Okay, I have a curve here, but I'm finding the area only going from A to B. I'm just finding that area under the curve within that interval. The indefinite integrals does not have those intervals. Okay, so I'll do an example of either type of integration. For an indefinite integral, okay, what I want to do is I need to find that antiderivative. So to find that antiderivative, I need to raise the exponent, so it's going to be 2x to the exponent of 4, and divide by the increased exponent. Minus 4x, increase the exponent, so the exponent of 3, divide by that increased exponent. And I need to put in my plus c afterwards. Okay, that c being your constant that you don't know yet. Okay, it could have been there when you did the derivative. It went to 0, and that's why it didn't exist inside here. Okay, the definite integrals where you have the an interval that you're going from. So I'm going from 0 to 3. So I only want to find the area under this curve that's going from 0, x equals 0, to x equals 3. And I want to find that area under that curve. Okay, so what I want to do here is I need to do the antiderivative. All right, so I'm going to actually put in square brackets the antiderivative, and on the other side of the square brackets I want to put that interval that I'm going from 0 to 3. And the antiderivative of this would be raise the exponent, divide by that raised exponent, plus c. Now I would take that antiderivative and I want to evaluate it. I'll evaluate it at the higher boundary and then evaluate it at the lower boundary. Antiderivative value at the higher boundary, and I want to subtract the antiderivative value at the lower boundary. So this antiderivative at the higher boundary of 3 is going to equal 3 cubed divided by 3 plus c. Subtract the antiderivative at the lower boundary, which would be 0 cubed divided by 3 plus c in brackets. Now when I go to subtract these two, I have a plus c and then I'll have to subtract another plus c. So the c's are going to disappear. So I'll end up with 27 over 3 subtract, and it's just going to end up being a 0 for 0 cubed divided by 3. My plus c and my subtract my other plus c are going to disappear. So I had 27 over 3, which is 9, subtract 0, and my answer is just going to be 9. The area under that curve is just 9 units. Okay? So a definite integral, you have actually boundaries that you're going to follow, and you're going to take your antiderivative, and then you're going to subtract the when you plug in the different boundaries. The higher boundary, subtract the lower boundary. Okay? And your c's are going to end up disappearing. So a lot of times, people won't even put the c into those square brackets because they know it's just going to disappear in a definite integral. In an indefinite integral, where you don't have those boundaries, you have to make sure you include the plus c. So it's just a little short lesson on introducing integration, okay? And you have two types of integration, a definite integral and an indefinite integral. Okay? Thank you very much.